Can you hear me? So again, strength is very low today. So where are the students disappearing? Let me share the screen and let's finish what we started last time. So most likely we will finish all the theory part today. And if we get some time next week, then we will talk about practical things. So we are talking about deep learning, and we see that it is a huge network of neurons with multiple hidden layers. And each layer has a well-defined role. And that is what makes the different flavor of deep learning architecture. One we had seen last time was called CNN, which stands for convolutional neural network. And we said that in CNN, the data is passed through various convolutional layers. And in a convolutional layer, there are a range of filters which are known as convolutional filter. This is particularly useful to capture the spatial dependency between the data points. And this spatial dependency of data point is useful for image processing like applications. Right? So we had seen that last time. We had seen that, let's say there is an image. It seems like there is some issue with headset. Let me change the headphone. Am I audible now? I have changed the headset. Can you hear me? Okay, so last time we said that let's say there is an image, some n cross n image, and if we, as we said, if we give it directly to the neural network, multi-layered feed-forward network, then the number of input will be equal to number of pixels. In this case, let's say if it is 28 cross 28 image, as the example we took last time, then that many input layer neurons are required. Other thing you can do is you can do some feature engineering, like line extraction or or curvature extraction, and based on that you can make prediction. So these two things you need to do with traditional neural network. But in case of convolutional neural network, you create a convolution layer which can extract features through filtering. For example, let's say if the data points are something like this, our image is something like this. So let's say 12, 15, 18, 24. Let's say if the image is something like this, then instead of passing this image entirely, what we'll do is we'll create a filter which we call convolutional filter. And this filter can be of any size. For our example, let's say our filter is of size 3 cross 3 filter. Let's say we are using a 3 cross 3 filter. Then the filter will first be placed at the beginning of the matrix. And the filter can have some values masked by making it 1, 0. Last time we said that if it is a line detection, vertical line detection, then the filter can be designed something like this. So what we do is we put filter at the beginning. We put filter at the beginning of the matrix, and we multiply the filter value with the cell value. So 12 multiplied by 0 is 0. Then 15 multiplied by 1 is 1. 18 multiplied by 0 is 0, and so on. 0, 1, 0, 0, 1, 0. And then we take a linear summation of all the values that we get after multiplication. So that will be 15 plus 26 plus 15. That turns out to be 56. Right? So the outcome of first filter value will be again a new matrix where the first cell is 56. What does this 56 indicate? The 56 indicates multiplication of this first 3 row and first 3 columns with the filter. In whatever summation we have found, that will be indicated by this first 0. What will be the value of second cell here? So I will wait and ask you, are you following me? Is this clear? Last time we didn't take questions as the lecture was towards, we have already taken our time given for the lecture. So are you with me up to this? Any questions? Because if there are no questions, then tell me what will be the value of second cell where I have put question mark. Okay, pooling layer is the question. We'll talk about pooling layer, Priyank. Let's first get through this convolution layer. Then we'll talk about pooling layer. So what will be the value at the second cell? Okay, General says 63. And why 63? Okay, so what we do is we now move the cell towards left. This convoluted filter will move one cell towards left. Is this what you have done, Janil? So if you move it towards left for one step, now the visible values which multiplies with 1 are 18, 35, and 10. And that is why Janil Deep and Janil and Deep are answering it as 63, right? So move the filter one step towards left and repeat the same process of multiplying cell value with filter value and then sum up all the values. So now the values that get multiplied with 1 are 18, 35, and 10. That turns out to be 63. So this will be 63. And so on. Do it for all the points. Now here you have design choices or parameters given for the CNN. So we have assumed that it will jump one step only, but while designing, you can jump more than one step also. Similarly, for size of filter also, here we have assumed that the size of filter is 3 cross 3, but it can be less or more than that also. And based on that, the image size would be reduced. If you use a filter of higher size, 5 cross 5 or 6 cross 6, and if you define a bigger jump rather than one step, then you can have a resulting matrix of smaller size. So this way you keep on filling all the value and you have output of convolutional layer. Right? This is one step. Now this is one filter image. This is one filter only for vertical line. You can create another filter for horizontal line similarly. Something like this. And multiply again with the table with this image and do all the things. So that will make another filter. And so on. Then you might define a filter for uh, a diagonal one value. So there can be many possible choices of filter, something like this, to see that how many diagonal lines you get in the image, and then you put another filter, right? So convolution layer has many such filters. So this cascaded deck of layers indicates the number of filters that you are applying on an input data. It can be any number based on size of the filter that you are using. Now, can you further reduce this representation? So that's why the pooling, the question that Priyank has asked, what is pooling layers? At the end of convolution filter, what you apply is pooling, and pooling is there are various ways. Out of this, let's say I don't want to go through all these uh, trivial computations, but let me put some numbers here. Let's say something like this. After running the first filter on 9 cell, you get this value, let's say. Now the question is, can you further reduce this representation? So instead of this 9 cell, if you want to use only one of that, then what you can do is you can pull any one of this value, and let's say that value is largest value. Then what you are doing is max pulling. Now you have a representation of only
that is 80. So these 9 cells are max pool to this one cell with the number 80. Are you with me, Priyank? Okay. Preet is also asking the same thing. Similarly, there can be average pooling also. Instead of finding the max, you take an average and return the values as average pooling. So this is pooling layer. Or it is as a part of convolution only, convolution layer, which has filter and pooling. So at the end of all this exercise, and this pooling for all the filters. So if you have 10 filters, then you have corresponding 10 pooling layers. At the end of this, you have a image representation in reduced dimension, which contains the important features of the image. And we believe that each convolution layer learns one feature of the image. And after that, you can give it to a multi-layered feed-forward network, which is designed for some classification task. Right. So this is a very broad overview of convolutional neural network. Training is again done through the backpropagation algorithm that you know. But the difference is now that rather than doing the feature engineering manually, we rely on convolution layer to do feature engineering. The number of dimensions in which image is represented is increased by the number of convolution layers that you are choosing. So that will lead to a deeper learning. That's why the deep learning, that you learn through many layers and you train many parameters. But as we discussed in last lecture, this is possible with the kind of processors we have like GPU and TPU with millions of weight parameters can be trained on a very powerful machine with graphical processing capabilities. And the architectures like TensorFlow, which I think you have seen with in your lab for SVM or for some other experiments. So those architectures are particularly suitable to do this kind of matrix operations that we are discussing here, convolution and pooling and all that. So it makes everything very efficient. Yeah, so that is CNN. I'll wait for some time and tell me if you have any questions on this.
The time is 14 o'clock.
Okay, any questions on this? Okay, so if there are no other questions, let us move to the next very popular deep learning architecture, which is known as recurrent neural network or RNN. Again, this works on the idea of learning through multiple hidden layers, and that is why it fits into this definition of recurrent neural network in the definition of deep learning model. But the way it is designed and the way it functions is slightly different from a convolutional neural network. So in convolutional neural network, we said that it exploits the spatial property of input data and tries to connect spatial group of input into different convolutional layers and then process the input. Here, instead of this spatial property, these recurrent neural networks are particularly suitable for the task of sequence labeling, which we have discussed earlier. In just a second. So recall that in last lecture we talked about the part of speech tagging where we raised this issue of sequence labeling, and we said that there are a range of problems where the output assigned or output label assigned to the previous input plays a role in deciding the output of the next input. So that framework is captured in recurrent neural network. So first, let us say we have a traditional multi-layered feed-forward neural network where we pass some input and get some output. So that is our traditional block of multi-layered feed-forward neural network. And let's say we are passing word and for which we want to predict part of speech. So let's say word is something like this, rely. And part of speech here is verb. So let's say encoding for verb is VBZ, right? And machine is trained, this weight values are trained in a way that it can predict the part of speech for, so these are the weight values of hidden layer and, oh, sorry, weight values of layer 1 and layer 2, let's say layer 1 and layer 2. So input and hidden to output. So these are the internal weights. So this way it will train forward rely. Now let's say The second word is upon, let's say. And I want to predict part of speech of this. So, in order to predict the part of speech of the word upon, is it useful to know the part of speech of the and previous word, that is rely and verb? What do you think? Do you think that knowing that the previous word was rely and its part of speech was verb is useful in deciding the next word upon and its part of speech? It could be, right? Please say that, because there are some only few words which can go after rely, rely on, rely upon, rely without. Can I write something like rely without, or I rely that, or I rely the? Usually, we don't see such constructs, right? So we know that after a particular part of speech and particular word, you will see a certain part of speech and word only. We have established this last time also. So while making prediction for this, again, let's say the neural network is same architecture, which predicts that the word rely will be used to make prediction for the verb upon. So again, the same way will be modified. But what if I want to also give an additional information about what was tagged previously? Then I need something from the previous input. Then I need some information from what was previously tagged. Right? So how do I do that? So I pass the previous output, which I have fetched from here, and add it in making prediction. So now let's start with nomenclature. Let's call this input X. Input X, let's use some other color. So this input X produces output Y, and the output Y goes here as output from the hidden layer to the next input. And here again this is new input X, for which the output Y is produced. So the same network, as happens with all the training examples and all the models, you give one after one training examples to the model, and model learns from the training example. In this example, the input training is given by words. So you pass one word as an input and you fetch one part of speech as an output. But only different thing that I'm talking here is that while making prediction for the next input, you want to use the information that you have gathered for the previous input. So the same network is passed the information about the next input. So this is actually not the correct representation. The representation that I have shown here is not correct because these are not different layers or network. Rather, these two are same network observed for different inputs. Just pay some attention and read this carefully and tell me, does this make sense to you? So I have given a block, one with relay word, one with upon word, and I have shown some network. So these two are not different networks. First, I have given relay as input and get an output. Then I have given upon as an input to the same network and get an output. So the network that I'm talking about is same, and that we are observing the behavior of the network for two different inputs. First, I have given relay as input, and then I have given upon as input. So it is just showing different input at different time, but otherwise it is the same network. So the diagram that we have drawn is not correct. So these are not different layers or networks. This is same network. Right? Do you agree with me? Right? So actual diagram should be something like this. Let's make a black box view of this. What I have done is this. Right? So this is input X, this is output Y, and this is hidden H. So this hidden actually goes back to this, and it is processed for the next input. But this is for next input. So we need some iteration. We need to maintain this counter. So if this is input xn, nth input and y output yn, then here you are getting the process x is for xn minus 1. In order to process input xn to find out output yn, you will need the previous hidden value, that is xn minus 1. So this is called xn minus 1. And again, if I start with this diagram, then it might look confusing, and many of you might get confused right now also. And that is why we use this kind of representation. This is called unfolded RNN. You unfold this for the input. So how many times this loop will iterate? Right? So it is reoccurring. That's why recurrent neural network. That's why it is named recurrent neural network, because it will reoccur. The same network will process one word at a time, one after another, until the entire sentence is processed. So length of the sentence in our example. So let's come back to our part of speech example like Ram eats an apple. So the recurrent neural network that we create for this. So what are the things you need to take care for designing a recurrent network? So you need to have a list of words and you need to decide the size of input. In case of CNN, we said that input size is dimension of image. So if it is 20 cross 28, then 28 cross 28 would be the input size. What will be the input size here? We are giving word as an input. The input size will be size of the word, but size of the word is not fixed. It can be varying. So how do you deal with that? Take the largest word or take the largest word and decide that size. So here largest word is apple with 5 letters. So the input size is 5. Right? So now if the input size is 5, how would you process the RAM? You left the two places. How do you fill in that? Fill in with nothing, zero. So this is called padding. Right? So the input size is solved. And what about output layer? How many output neurons you need? It depends on number of POS categories. How many POS categories you want to deal with? For example, noun, proper noun, verb, adverb, adjective. Let's say we are dealing with 5 categories, then you need 5 output layer neurons. So your network would be something like this: 5 input layer. Of course, there will be some encoding and other things which we are ignoring for now, and 5 output layers. And whatever hidden layers you want to put here, beside the hidden layers, and make a fully connected network. And so this is input X and output Y. But we said that along with input X, we also want to see what was predicted last time, right? This rely upon example, we said that to make prediction for upon, we want to see the rely and its part of speech. So for that, you need a hidden layer also. So start a hidden timestamp. So let us say this is X1 and Y1. First input RAM, and these neurons will not just read uh, input X, but it will also read hidden 0. That is from the previous output. And first for first word there is no previous output. So there is lambda or null initialized. So maybe all set to some default value, which does not make any difference in the prediction. Maybe 111 or something. So this output here will be H1, which is equal to all the weights multiplied by X plus some other set of weights multiplied by H0. That will give you output H1, and this H1 will map to some function Y1 is equal to some weight into H1, which will give you the output representation. Are you with me? Just spend some time and see if try to relate it with the forward calculation of your traditional neural network and tell me if you are confused at any stage or if it is difficult to understand. Right, so the more or less the way we are discussing, we are trying to make it look like feed forward neural network. Only difference I am making here is that if instead of y is equal to fx, now we have y is equal to f of x comma h0. This is what I am saying. Y is equal to not just fx, but y is f of x comma h0, previous 0. I don't know. So yn fn and h n minus 1. And this is what I'm saying. In case of traditional networks, the yn was f of n, f of xn. Whatever x you are observing, from that you produce y. Now I say that with xn also there is something hidden called hn minus 1. Does this make sense? So hn is initialized separately. In first case it is h0, which is separately initialized. X1 is the first word as an input. Both goes through certain weight multiplication as we do in neural network, and we get some output. We call that output H1. We process the H1 to produce the output representation the way we want, and that we call Y1. And then we move to the next word. So after processing RAM, the next word that we want to process is speech. So now again the it will go as second input called X2. When it goes as second input X2, the corresponding H0 is now updated to H1, some new value. Right? Depending upon whatever output you have got last time, this might get updated to something like this, and so on. So again, this will multiply with it and it will produce some output Y2. Then again, and then apple. It will process the every word of sentence one by one while updating the corresponding weight values and hidden values. Right? So this is recurrent neural network which can capture the dependency between the outcome of previous input and the next input. Right? The sequence labeling problem that we talked about. It has particular application in many problems. So part of speech is one that we have discussed. Another is speech to text and text to speech processing. Then language generation, that is fill the missing word, predict the next word, and so on. So these are the kind of applications where RNN has shown a very significant result. And this field has evolved now. So from RNN we have bidirectional recurrent neural network, then we have attention mechanisms, now we have transformer based models, pre-trained models. People have, because the deep learning, as I said, has millions of parameters for which the single machine or few machines are not capable. You need a huge uh, network of powerful machines to process this kind of uh, weight parameters. And that's why the cloud computing, cloud frameworks like Amazon Web Server or Google Colab, all these are the platforms where nowadays even companies are hiring these platforms to run their programs. Nobody maintains such huge servers on their own. So nowadays the neural network and deep learning based machine learning field is working is that you hire such this AWS service or Google Colab service and run your program on GPU and TPU and get the results and use the model for your applications. Only few companies like Google or Facebook, which has this infrastructure, can train, and also they have availability of infinite data, as we have discussed in very early lectures of machine learning, that we are very generously creating data all the time. And Google and Facebook mostly have access to this data. So they process our data on such huge systems and make predictions for us. So they are the pioneers and they train this kind of model. And once they train the model, they release it for public consumption. So that gives us some pre-trained models. So they have trained the models on millions of data points and given us this kind of model. So usually this kind of models are transformer-based models. So this is beyond the scope of our discussion, but I should certainly point to the libraries that you can use. So one is TensorFlow, right? TensorFlow library is from Google. Another computing library is called PyTorch. PyTorch is, I guess, from Facebook. Yes, PyTorch is for Facebook. Is from Facebook. Facebook AI Research has released PyTorch. So if you want to write your deep learning program, you need to know this kind of libraries. And if you want to use some pre-trained model, then there are some transformer-based models like BERT and many variants of BERT, which you can use for your purpose. And for that, now there is a library which gives this kind of pre-trained model available to you, and you just need to use those models for your purpose. One such popular library which everybody is using nowadays is Hugging Face. Please go and search on internet how to use Hugging Face library and all that. So yes, it has a very involved theory, but I guess we have the overview. And from application point of view, there are a lot of resources available which you can directly explore on the internet. That's why I'm leaving you with these keywords so that you can explore it yourself and try to use it. I will stop here. Maybe we can spend 1 or 2 minutes for questions. And if we get some time next time, I think we have covered most all the syllabus. But if we get some time, then we'll see some practicals and get our hands dirty. Yeah, so that's it from me. Any questions? Okay, so if there are no other questions, I stop here. Thank you.